This is so cool. Finally, full color 3D printing. This is amazing. How does this work?
Actually, just jet the ink and cure the ink with UV light.
Okay, yeah, awesome. So like spraying it out of some nozzles.
Yes,
yes. Awesome. We've got an example of what you're printing, which is gorgeous. This is such a pretty model. It shows it off so well. This is amazing. This is Scott from HeyGears. What's your role here?
I'm the CEO and the co-founder of HeyGears.
Okay, the big boss. This is your G1X series that you're launching. Now, what's going on with support? Why do you put support around the entire print?
Because this is inkjet technology, so once you jet the ink, you have to fall on some plates. So if it's not on the surface, it will be on the bad surface.
Okay. So you can't even have like a millimeter of overhang?
No, because the liquid viscosity is too low, so you don't have.
Got it. So how do you remove this?
Let me show you.
Okay, great.
This is Liang Gong. He's our lead engineer for G1 series product.
Yeah. And he's going to show us how you guys remove the support.
Yeah, definitely.
Awesome. Okay, I'll let you go.
This is the water inside, and this is our print, and it's the water support.
Yeah, so water-soluble material.
Yes.
Here. Yeah.
Okay. So I will set up the print inside, and I will have the camera to have a time shot.
How long does this usually take to dissolve?
Maybe about 6 or 7 o'clock. But if we have heat, and it will faster.
Okay. So we're speeding it up. We don't have heat in here right now, but we've got a pump running.
Yes.
Okay, just to circulate the water.
pump.
Okay, awesome. Yeah, let's set it up.
Okay, so now I will put this inside.
Yeah, perfect. And you got it just mounted on a piece of glass for weight.
Yes.
Yeah, cool.
And then I will turn on the pump.
Yep. Perfect.
Okay.
Sweet.
So this disappear.
Yeah. Gradually dissolve.
You know.
Okay. I want to hear more from you about what you and your team are doing, specifically about the 3D side of things. What's more challenging about the 3D than the 2D UV printing?
Yes, I will show you upstairs in my lab. Okay.
Yeah, sweet.
Okay.
And just so you know, HeyGears is sponsoring this video. Oh. Yeah, this is cool.
Yeah. Coming here.
Oh, okay. So Liangong, you speak a fair amount of English, but we're talking about some really technical things.
Yes.
So you said to us, maybe we can do a mixture of English and Mandarin so that you can speak in your native language for the more technical parts. Is that right? Yes. Perfect. And then we have one of your colleagues off camera who speaks technical English a little bit better than you, and she's helping us translate. I have some idea of what he's saying, even though my Mandarin isn't great. So yeah. Perfect. Okay, awesome. Let's get into this. Liangong, explain to us, how do you make a 3D print out of UV ink? Like, how does this process work?
With color printing, it's actually made up of several parts. First, there's our color ink droplet. Then there's our body ink. Then there's our support material. Once those come together, only then can it print up layer by layer.
Got it. And so you're spraying out little tiny dots of each ink. And so you've got a microscope here that can show us all those little dots. So we've got, this is a test with cyan, right?
Yes, it's showing blue right now. And on this film, we've actually jetted yellow, red, gray, and also our white and our support as well. And through this confocal microscope, we can see the state of every droplet and whether each layer is flat. We check the state of every droplet with this microscope. Observe, measure. Then once we confirm every layer is flat when they're stacked together, that's what gives you flatness in a 3D print.
Like, what's hard about 3D printing versus 2D printing?
Other companies, the ones doing 2D printing, are mostly in the traditional UV industry. In the traditional 2D industry, if one layer isn't flat, it's not really noticeable. But in 3D printing, if one layer isn't flat, once it stacks up, you get a lot of grooves and valleys, and those grooves affect the final formed result.
So we can see here, we can move this around. You've got a piece of film here with a bunch of dots that you've printed. It looks like you're trying to leave individual dots, but you've also got places where they merge together. And then you're using this to calibrate how much ink is coming out of the head, is that right?
Yes.
Yeah, and then you also, you're not just looking at this from the top down. This is a special microscope, which I want you to explain how it works, because this allows you to measure height as well.
It's through its focus, the confocal microscope, it actually uses different levels of sharpness to determine height. So it uses an optical principle to measure, to see each frame's state and then measure the final result. So I will show you.
Okay, show us how you do it.
Here is the blue color.
Yep.
So we focus it. We need to see where the focal point is. And then we set the approximate range we want to capture. Here it's 20 microns.
Got it. Okay.
And now he can see it's continuously capturing, going between in focus and out of focus to obtain the 3D model. And once we've obtained the 3D model, then we do the measurement.
Oh, this is cool. This is really cool.
Right, and here you can see all of the droplets.
Oh, yeah. So now you have basically like a cross section of your dots here, and you're showing your heights this way.
Yes.
And so you could show your height variance.
Yes.
Got it. So this one obviously is just a piece of film with one layer of very, very sparse droplets. Are you also doing samples where you're building up multiple layers and then seeing the surface texture that you get after stacking multiple layers?
We do use this instrument on 3D samples, but because with a 3D sample, it combines more variables, not just whether each ink layer is flat, but also some related coalescence. Because the jetting behavior varies, the size of the jetted droplet, you get some coalescence or some scatter. But we use our RIP algorithm plus our own process algorithms to make the final result flat. And on this equipment, you can also see that flatness after doing a before and after comparison, the result shows up again through this equipment.
So on a single layer or on multiple layers?
Multiple layers.
Multiple too. Yeah. Awesome.
It's a droplet observation instrument. It's used to observe the state of each droplet falling from our printhead.
Okay, so this is like a high-speed camera rig that you can actually see the droplet coming out of the nozzle in the printhead. And so are you running a whole bunch of different tests for all the temperature, different materials, different inks, different colors?
Yes, and not just through the one we saw a moment ago, the microscope. This is also a very important piece of equipment for us, used to confirm how droplet size changes under different conditions. And on top of that, different waveforms can control the droplet size. So it's not just a way to observe the droplet, it also lets us control the number and size of droplets.
That's awesome. Let's see this in action here. Can we fire it up?
Yeah. And right now we click here to turn it on.
Yep. Oh, that's cool. Okay.
Here are the droplets falling one by one, and a high-speed camera captures the whole process of the droplet falling. And here you can see two droplets merging into one big droplet. That's the different droplet sizes we mentioned, and we control it through the printhead voltage.
Awesome. Let's talk a little bit about the printhead itself, because you have a couple different options. You chose a different printhead for doing 3D than you did for 2D. So let's talk about that.
The printhead we use is the i3200 printhead. The i3200 has 8 channels because in 3D printing we have CMYK plus W plus support and clear. And to get the jetting result across all those channels, we need an 8-channel printhead. With something like the 1080 printhead, the viscosity it supports is too low, so it can't bring out the material performance of 3D printing. Because with 2D printing, performance comes mostly from the substrate, but with 3D printing, it's the part itself, its mechanical performance. To guarantee that, first we need viscosity, second we need enough channels to get more colors.
How do you ensure that it's strong enough? Is the printhead affect that?
The prerequisite for guaranteeing strength is guaranteeing our material's performance. As for material performance, the lower the viscosity, the worse the mechanical performance after curing. So if we want to guarantee mechanical performance, we want to use the highest viscosity material we can. Its performance will be better. And on top of that, besides using this printhead, we also heat the printhead, which brings its viscosity, the ink's viscosity, down further. Bringing it down further means we can jet a higher viscosity ink, which gives better 3D mechanical performance.
So these are all Epson printheads. It seems like Epson is pretty much the only solution right now, right? Like you have to buy an Epson printhead, right?
Currently, within the Epson lineup, the 3200 is actually a very good, well-supported printhead because of the ink performance and viscosity it supports, and its overall lifespan is also much longer than the 1080s, and then its nozzle density makes both the print quality and the print speed better.
So one thing I noticed on this rig, which is super interesting, is over here, there are two fiber lines coming in. It's not copper wires.
Yes.
What's going on there?
When we do 2D printing, you can actually print using a traditional FPC ribbon cable, but for 3D printing, it runs 24 hours continuously, and it may even run for quite a long stretch, because the objects it prints are big and thick. When it runs that long, its demands on the cable are extremely high. And with a traditional FPC ribbon cable, its life is maybe only a few 100,000 cycles. But currently, if we replace it with fiber optic, we can reach millions or even tens of millions of bend cycles, which is what it takes to support stable 3D printing production.
Okay, let me just make sure I got this straight. You're using fiber optics because it is stronger and lasts longer than a ribbon cable that made out of copper lines.
We use fiber optic mainly because it lasts longer, right? That's the main one. And second, it actually improves reliability because, as you'd expect, electrical signals, when things are moving or near a motor, pick up interference. But fiber, throughout operation, exists as light, so it doesn't pick up interference. So that's why we use fiber. One is interference immunity, the other is its lifespan.
I'm just super surprised by that because usually we think of fiber optics as being super fragile and copper as being much more resilient. That's crazy. That's crazy. That's amazing. I would not have thought of that solution, but I'm impressed. Let's talk more about color, because you were saying there are a bunch of things that affect color. It's not just how much ink comes out of the head, but there's all these other factors. Tell me what's involved in getting good color, and then how do you calibrate it? How do you test it?
We use our own in-house set of color algorithms to achieve 3D color reproduction. And in the traditional 2D algorithms, there's no way to achieve 3D reproduction on a three-dimensional model. So we have our own original algorithm, and this algorithm does the color calibration through this instrument and equipment. And that's how it achieves 3D color reproduction.
Okay. Got it. So this is like a color meter. You have some calibration. This is your 2D stuff, right?
Yes, this is the 2D color.
Yeah. And this is standard, like industry standard?
It's standard.
Yeah.
Yes.
Okay.
What this shows is the precise jetting relationship between its color and the lines. And what's presented here is some of the detail it can print, including some gradients, and including how fine the text we can actually print is.
So this is your 2D swatches.
Yes.
This is your 3D swatches, which is like kind of totally different, right?
Yes.
Yeah. So explain why these are different.
Because with 2D color, it's only a few tens of microns of color reproduction, and it reproduces the color through a reflection off the base, the white reflection underneath. But 3D is different. For 3D, it's through a certain thickness that it reproduces its color. So there are two ways of reproducing color, and their overall strategies are different.
And just so people know, like if people aren't familiar with micrometers, about 100 micrometers is the thickness of my hair. It's also the thickness of a piece of paper. So like a piece of printer paper is about 100 microns. Yes. So it's about a third of that is your typical layer for this.
Yes.
Whereas this, you're building up many layers. I think you said this ink is maybe a little bit more see-through. So you see layers below just the top layer here.
With 3D ink, the color does read a little darker, but our color reproduction, it doesn't depend entirely on darkness. It also depends on the layout within the area. So its strategy is different from 2D. It's a more three-dimensional way of reproducing color.
Let's explain what you're doing here, because you got all this fancy hood, you've got a fancy color meter. What do you do now?
First, we've already opened the software here, and once it's open, we set part of the color based on the color chart we printed to set up our color measurement. And in this system, in this software, based on the color chart we printed, it can calculate our ICC curve, and through that ICC curve, we can see the differences between our colors. And after we print this color chart, then we use this instrument to compare it against the actual color, and from that determine how our current color and the color we need differ.
Awesome. We wanted to talk about these. This is your bad sample, and this is a pretty good one. What causes the ripples?
These are our different inks, and achieving flatness here, as we talked about today, is very much tied to the ink, and then also its flow, pressure, including our printhead's jetting voltage, which also affects the final flatness. And what we're showing here is mainly how the ink affects flatness, including the ink's flow and surface tension, and its viscosity and the curing power, all of which affect the surface result. And this one is done being tuned. It's close to our final production ink, and this one is our early version. And here you can see it has a lot of nozzle dropout, and it's in a very irregular state.
So what are these samples now?
This is one of our prints, a print from before versus our print now. And before, the color was off, and there was some color bleeding. And now we've optimized that bleeding, and we've made a fairly big improvement in flatness. We'll be adding more software strategies, including hardware strategies, to get a flatter surface and better color.
Sure, of course. Always improving.
Yes.
Yeah. So I want to learn more about how you guys are making your materials.
Then let's go over to the materials lab and take a look.
I'm really curious, how is the ink that you're using for 3D printing different than your 2D UV ink?
The main reason is that with 2D, it relies more on the properties of its substrate, but with 3D material, it relies more on its own properties.
I think you mentioned earlier that one of your challenges with color is that your 3D ink is, I think you said paler, but maybe more transparent than your 2D ink. Is that true?
Correct. 3D ink is more transparent than 2D ink, and the reason is that the logic of its color reproduction is different. With 3D material, it bonds to a degree with its support, and when it bonds, there's a certain amount of intermixing. If we designed it to the color reproduction thickness of 2D ink, if we designed it that way, then once the 3D water-soluble support bonds with our color, it would eat away or strip off some of the color at the surface. So with our 3D ink, the color layer has to be a little bit thicker to stand up to our water-soluble support and to stand up to our post-processing steps, so it reproduces the real color. If there were no support, we could actually design the 3D ink to be more opaque. If we designed it more opaque, its transparent shell would be thinner, and if it's thinner, it can actually deliver the color, whether that's opacity or transparency, it would be better. But precisely because with 3D, because it bonds with this support material, so it's inevitably going to have a little bit of transparency in it. It just can't be made that opaque.
Okay, I understand. Now, you guys are also doing some material testing in here. Tell us about, you've got a machine over there, you've got some samples here. Tell us about what those are.
Yes. This is our water-soluble support material, and here we run some experiments here, testing all the different formulations, testing how fast it dissolves, testing whether it meets our support performance requirements. And here we run a great many tests and then map out the limits of each version and finally pick one version to put into our 3D model.
Yeah, got it. So you've got it on a stir plate back here with a magnetic stirrer, and they're just circulating the water and then seeing how long it takes to dissolve. Yeah. And then what's the rig you've got in back, the testing rig with the weight?
We use that machine to test our material's performance, its strength, and besides that machine, we have other equipment that tests elongation at break, measures, tests its elastic modulus, and those let us assess whether the material's performance can meet the real demands of 3D printing.
Awesome. Okay, let's go see what's in this little room here, because you've got a really cool machine there for testing a totally different property.
Okay.
Yeah, lead the way.
This is a Fourier transform infrared instrument, and we use it to check our material's conversion rate. Because our material starts as a liquid and it has to convert to a solid, but during that conversion, what point it's reached, what degree, we observe that with this instrument.
So tell us a little bit about how this works. I know it's pretty technical, but give us just like a brief explanation of how it tells this.
We put our sample on it and run a test. Its measurement principle is a broad infrared spectrum emitting a light source down, which interacts with our material and reflects back. Generally, the chemical bonds in the material will absorb or reflect that broad infrared spectrum, and some chemical bonds, they take those infrared wavelengths and absorb them. So the spectrum that reflects back is missing that part, and from that change in the spectrum, we confirm which chemical bonds are present, and from specific bonds, we determine our cure conversion rate.
And you guys are using this not just for developing your 3D printing ink, but other materials as well. So yeah, totally makes sense. Liangong, thank you so much. Really appreciate it. I'm gonna go meet with Wayne. We're gonna talk about the software side of things. Okay. I'll let you get back. You're a very busy guy. So.
Okay, thank you.
So Wayne, I want to talk a little bit about how the software process works, specifically around like the slicing and the algorithms for figuring out where you're going to put the ink dots, because it's a little bit complicated, and particularly once you get into the 3D, it's totally different.
Yes, so the first step is the slicing. The slicing is to convert a 3D object to 2D images. You know, the 3D object is being presented in several meshes.
Yeah.
A mesh is a triangle.
Yeah, sure.
Yeah. When we're doing the slicing, we calculate the intersection edge between every triangle. So that part is the intersection edge.
Yeah. Mm-hmm.
So each edge around the same layer comes up to a full contour of the image.
Yeah. And so you basically then can turn that into like if you have let's say you have some object here, you can turn that into a two-dimensional version of that slice.
Yeah.
But it's actually like all these straight lines here.
Yeah.
That are your triangles.
Yeah.
Yeah, okay.
Exactly.
Yeah, got it.
Yeah, but the tricky part is that when we're doing it in full color 3D printing, we need to color the edge.
Maybe we should use a different color here, right? Like this section might be red.
Yeah.
Yeah.
Every section should be composed with the same YK. So the question comes to how can we calculate the color of every edge or the every point on the every edge?
Yes.
Yeah. So the first question is the color presentation.
Yeah.
Yeah. We represent color with RGB.
So red, green, blue.
Yeah, red, green, blue for each.
For each vertex here, for each point that make up the triangle.
So we calculate every point on the edge.
Okay. Yep.
Yeah. So we calculate
based on mixing these three.
Yeah.
Yeah. Got it.
This is the process of slicing. After slicing, the important step is the RIP algorithm or raster image processing. This processing is going to convert the color image into dot image.
Okay.
Yeah, dot image for each channel. I'm going to come to the RIP or the raster image processing.
Yeah.
The first step of the RIP is to mapping the two different spaces from RGB color spaces to the printing used CMYK space.
Yeah.
So first I'm going to do some mapping, and the mapping is controlled by the ICC profile. And there's a second step, we will go into several trivial processes like the image scaling to fit different DPIs. But the real tricky step comes to the third step, or the half tuning. The half tuning is going to convert a grayscale image into dot image.
Got it. And so like basically what we're talking about is like if this is your image, right? This will be your layer. So you might have like a super dark area here, and then you might have like a less dark area here. I can't really shade with these markers.
The half tuning will convert this gray image into dot image. So we'll come to different area with different dot density.
So you're doing like really high density dots here, and then like less dots here, and then just like a few dots out here.
Yeah.
Got it.
So the real difference between 2D rig, between 3D rig, is a color representation. It's not only from the flat or the two direction, it comes from 3 dimensions.
Right. Yep.
In the UV printing or 2D flat printing, the color is represented from its flat neighbors. It's X neighbor and Y neighbor. But when the things come to 3D printing, the color is not only presented from its X neighbor and Y neighbor, but with both Z neighbor. In 2D or in UV printing, we could simplify the question on a single layer. But when it comes to 3D printing, we should take account for its several beneath or up layers.
Sure. You were saying that there are the 2-dimensional RAP algorithms. You can find those.
It's mature. It's mature on the industry.
And there's other maybe open source algorithms or whatever. It's very easy to find code for this.
At least you can buy.
What about this?
You have to develop yourself.
Okay. So you guys have developed your own 3D RAP algorithm.
Not only the color part, but when we're talking about 3D printing, it also the shape is very important. So we're not only to think about the color itself, we're going to think to make each layer even and flat with the same amount of dots, with different dots together.
Got it. I can tell as a former software engineer, this is not easy. How long did you guys spend developing your own RAP algorithm?
Since 2024, there are a lot of more ideas we have that we have not implemented yet.
Well, this is super cool. Thank you. Thank you
You're
for
welcome.
explaining this. Yeah, this is a good explanation.
Oh, this is Scott, and I will hand you over to him.
Okay, awesome.
Let me show you the other part of our business.
Yeah, great.
We founded HeyGears in 2015, and we dropped out from the university from the junior grade. Yes, that's a kind of story if you succeed, right? At the first time, we figured out that the first project is to do the true wireless earbuds, and we use 3D print technology as the manufacturing method because we want to implement the iPhones or the mobile phones with a camera to scan the ears and to do the modeling, and you can fit it to anyone else. But later then, Apple come out with AirPods, so that's kind of end of the game.
Sure. Yeah, it's hard to compete.
Yeah, it's very hard to compete, so you have to go to very niche market, but we figure out that the top line is not good enough. So we are trying to see if 3D printing technology can implement to the other industries. So that's why we came out with our dental business.
Got it. Why dental?
Dental, is they can afford for more expensive like resins, the machines, and the customizations, for everyone different. And also there's a need rapid manufacturing method. So and all the softwares and the scanners are all digital, so you can implement into your system.
Got it. How much of your business right now is dental?
For dental, it's probably 80%.
Okay.
It's growing very fast right now every year. So we're growing kind of like 40 to 50% each year. So it's growing very fast.
That's crazy.
For the Chinese market, we are nearly like 60% of the Chinese market. And for the US and the European market, it's growing also fast.
Those are crazy numbers, Scott.
Yes, of course.
You must be super proud of that.
Yes.
That's amazing. Let's go see what else you're doing.
Yeah, sure, definitely. This is the other part of our business. We call it the reflex series printers. Actually, first time we come out with this one because we think we have quite good succeed in the dental business. So we try to expand our domain and try to get into other business. But to figure out that for dental, it's more affordable for the resins and the machines. But for the other part of the business, it's very hard to do that. So we are trying to minimize our technologies and fit into the size that everyone can pay for it and everyone can use it.
Yeah.
As it's more affordable for that.
What are you most excited with this new product, with this new part of the company?
I would say the potential of the products actually, that's very interesting for us because if you can apply the color to the surface and you also can provide the color into the space, so there's no limits, seems like, right? So we are kind of interested in that, how we can bring the 3D technologies into the next stage.
Yeah.
That everyone can not only use one technology to use for their hobbies or small business, but the others can provide commercial grade products.
Well, this is super exciting.
Yes.
I'm super excited to get to come see your printer. And thank you so much for sponsoring this video and bringing me and my team out here.
Yeah,
this has been a total pleasure.
Thank you.
So,
it's my pleasure.
Thank you. Okay, we're gonna get back with Wayne, talk a little bit more about the printer, and we'll let you get back to your busy busy meeting chair.
Yes.
Okay.
Thank
awesome.
you.
Thank you.
Fantastic.
This is super cool. I want to take a closer look at some of your samples because we really haven't seen that many yet. I noticed you have some other stuff embedded in clear resin. This one jumps out at me, this little guy in his box. So this is quite cool, a big tall bust. And then you've got your chameleon here, and this you printed in 2 pieces?
Yeah, the under part and the laser itself.
Yeah, awesome. I know because I accidentally dropped the top of it while we were setting up. But what's the max height you can print? How tall?
150 millimeters.
Okay. I really like this. You have some cute little keycaps here. So like the keycap part there. Yeah. So you can make a hamburger key for your keyboard. The mechanical keyboard community is gonna love these. Let's talk about ink. Do I have to use your ink?
We recommend our official inks. Yeah, but we don't have any hardware or software lock.
And then of course you've got 2D as well. Like this is not just a 3D printer, it can do 2-dimensional as well. So you have all of the Mona Lisa and magnets and books and things, which look great. The covers look great, super cool with textures and everything. This cool dragon head here, lots of details and lots of texture on it.
Ink circulation is very important for the white inks. We have 2 circulations.
Okay.
One is the ink from the tank.
Yeah.
And there's a resin station.
Yeah.
And the other circulation is ink from the ink tank to the printhead.
And then you're circulating it within the bottle or within the tank? You have a stirrer somewhere, right?
Yeah, magnetic stirrer.
Yeah, where? Here or there?
Both.
Both. Okay.
Yeah. We have 2 white channels for in the ink tank. Those 2 are the white channels.
Got it.
Yeah,
okay.
so both channels has magnetic stirring.
Yeah, okay. Just to keep everything stirred up.
Yeah, ink station has 2 white.
Oh, okay, 2 white tanks. Yeah.
Yeah.
Okay, cool. What's the cleaning situation? How do you clean the head? If I want to swap out inks, how does that work?
Typically, user is not recommended to clean their printhead very frequently.
Okay.
It is only need to be cleaned when user swap from UV mode to 3D mode or from 3D mode back to UV mode.
Yeah.
Every time the printer is leaves the printer standby, the printer will spray a little inks and to make the ink paths smooth and prevent clogging. So what's important is to keep the electricity on or keep the printer
right. You don't want it
standby.
sitting off for a long time or you'll end up with a clogged head. And then if you do need to turn it off for like you're moving or something, what do you do then?
To attach a moisturizing film to the printhead.
And then you have cleaning fluid for like when you're switching between 2D and 3D, there's a flush that happens.
Yeah.
And it does that for you?
Yeah.
Now, how do I swap out ink? Let's talk a little bit about what this is. So this is specifically for 3D printing, right?
Yeah. This is called the resin refill station.
Yeah.
And it is designed to refill the resin to the ink tank.
Okay. So for 2D, you just have this, but if you want to do 3D, then you need to buy this separately?
Yes.
Yeah, okay. Now this, for the 2D printer, if you don't have this, can you just refill by hand?
Yeah, sure.
Okay, cool. So you don't have to buy the whole like plastic cartridge and everything. You guys just have bottles. Yeah.
This is a UV ink refill bottle, 300 milliliter or 300 cc per bottle.
Awesome. And then you just pour it in the top here?
Yeah.
Sweet.
Insert the mouse into the small cartridge.
Yep.
And
Just squeeze.
switch it.
Yeah, easy. Sweet. How does your price compare for the ink compared to other manufacturers?
It is about 50% cheaper than the typical inks on the market. So the price is under $50 for 300 cc per bottle. And for 3D printing for the resin, the price is also under $50 for one bottle.
So 1 liter is under $50. Mm-hmm. Interesting. Well, this is pretty exciting. You guys have 2 different models, right? This is the G1X, which can do 3D printing.
Yeah.
And then what's the other one?
G1, more similar to the traditional UV flat printer.
And then you're doing a Kickstarter on this. If you would like to learn more about these printers and get one of your own, go to the link down in the description. Wayne, thank you so much.
You're welcome.
You guys are building an amazing product.
Thank you.
Yeah. We'll see you again soon.